So let's jump back into some stoichiometry with some limiting reactant practice. Now I know my problem is going to be a limiting reactant one if I see there's multiple quantities initially for my reactants. So if I see I have multiple masses, multiple moles, or even volumes, and I know one of those has to be the limiting reactant, and it's the one that will determine how much product can be produced. I have to figure out which one of those reactants I'm actually going to do my stoichiometry with. And to do that, you just set up a little dimensional analysis, no different from your regular stoichiometry, really. Use your balanced equation. It tells you which one will be the least and which one will be the most. On these practice problems, if you want to pause the video, work the problem out, and then check your work after, I highly recommend it. I will be rounding the atomic masses off my periodic table. Keep that in mind as you're doing your work. So that said, let's jump straight into it. Let's work out some problems and see if we can't figure this stuff out. So our first problem says, how many moles of water will form from the reaction of 5 moles hydrochloric acid and 3 moles sodium hydroxide? First thing I notice is I have 5 moles and 3 moles. I have two quantities for my reactants. That means there's a limiting in play. I got to figure out which one of those is the limiting reactant. And since it's already in moles, I don't need to do a mole conversion. I simply look at the balanced equation. And this reaction is already balanced for us. It's just a 1-to-1 to 1-to-1 ratio. So let's figure out which one is going to be the limiting reactant. Though it should be pretty obvious since it's a 1-to-1 ratio, the one that's the least amount is going to be your limiting. But we're going to do the math just to have good practice and to check anyways. So let's start with hydrochloric acid. And we'll see how much sodium hydroxide we need to fully react that 5 moles of hydrochloric acid. So I got 5 moles hydrochloric acid. I put that over 1. I set up my balanced equation ratio. Since 5 moles HCl is on top, 5 moles HCl goes on bottom, and I'm converting it to moles of sodium hydroxide. Now I need some values here, so that's your balanced equation. It's just a 1-to-1 ratio. So I got 1 here, I got 1 here, and I got that from the balanced equation. So before I do this math, I cancel out my units. So 5 times 1 divided by 1 gives me 5. And what's left over is moles of sodium hydroxide. So what this tells me is I need 5 moles of sodium hydroxide. Well, how much do I have? How much do I have available? Well, that's 3. I have 3 moles of sodium hydroxide. So if I need 5 and I have 3, do I have enough? Well, the answer is no. So 5 is larger than 3. And my saying was, if the left number is larger, then it's limiting. Left, larger, limiting. So sodium hydroxide is your limiting reactant. And if sodium hydroxide is your limiting reactant, hydrochloric acid is your excess reactant. So any stoichiometry work we do from here on out, we're going to use sodium hydroxide, and we're going to completely ignore hydrochloric acid unless the problem specifies something about it. So let's continue on. It says how many moles of water will form. So we're looking for H2O, and we're looking for how many moles of it. So now we're just doing regular old stoichiometry. So if I got 3 moles of NaOH, I need to figure out how many moles of water will I produce. So first we got to do our ratio between sodium hydroxide and water. Sodium hydroxide is on top, so I put it on bottom. That means moles of water go on top. Now I need some values here and here. Use your balanced equation once again. Since it's all just a 1-to-1 to 1 ratios, a 1 goes here, a 1 goes here. Sodium hydroxide moles cancel out. So I got 3 times 1 divided by 1 is 3. And that's going to be 3 moles of H2O. And there is our first answer. Now let's look at another one. It says calculate the mass of sodium bromide formed when 75 grams of nitrogen tribromide and 60 grams of sodium hydroxide react. Seems like a lot, but it really shouldn't be. So let's just pick out what information we do know. It says we're going to calculate the mass of sodium bromide. So sodium bromide is NaBr3. So I'm looking for sodium bromide, and I'm looking for the mass. I'm looking for the grams. I got 75 grams of nitrogen tribromide, and I got 60 grams of sodium hydroxide. So I got two masses. One of these guys is the limiting reactant, but in order to figure out which one, I got to do mole conversions because I can't use mass. We got to do a mole conversion first. I got to change the 75 grams of nitrogen tribromide to moles. So 75 grams nitrogen tribromide, put that over 1. So 1 mole of nitrogen tribromide is equal to how many grams of it? So let's use our periodic table here. So nitrogen is going to be 14 grams, and I'm rounding to the nearest whole number. Bromine is 80 grams, and there's 3 of them. So I multiply it by 3. So that's going to be 254 grams for the molar mass. So I do 75 times 1 divided by 254, and I'm going to have 0.3 moles, and I am rounding that from 0.295 to 0.30. Nitrogen tribromide. Now I got to figure out how many moles of sodium hydroxide are there. Well, I got 60 grams of it. Put that over 1. So 1 mole of sodium hydroxide is equal to how many grams of sodium hydroxide? Well, sodium, it weighs 23. Hydrogen weighs 1. Oxygen is 16. Altogether, that makes 40. 40 grams for a mole. So 60 times 1 divided by 40, we got 1.5 moles of sodium hydroxide. All right, so we got 0.3 moles of nitrogen tribromide, 1.5 moles of sodium hydroxide. So a quick look at my ratio says I should have 2 nitrogen tribromides for every 3 sodium hydroxides. So let's do our dimensional analysis and see if we actually have that. So I'm going to start with nitrogen tribromide. So how much sodium hydroxide will I need to fully react 0.3 moles of nitrogen tribromide? So I got 0.3 moles of nitrogen tribromide. I'll put that over 1. And I'm trying to figure out how much sodium hydroxide do I need to fully react this amount. So I got to convert my moles of nitrogen tribromide to moles of sodium hydroxide. Nitrogen tribromide is on top, so now we put it on bottom. Moles of sodium hydroxide will now go on top. And we said our balanced equation was 2 nitrogens for every 3 sodiums. So this is going to be 3, this is going to be 2. Moles of nitrogen tribromide will cancel out. So we're going to do 0.3 times 3 divided by 2. I need 0.45 moles sodium hydroxide. That's how much I need. Well, how much do I have? I go back up to sodium hydroxide. I got 1.5 moles of it. I need 0.45. I have 1.5. The right is larger, so that means it's excess. So sodium hydroxide is in excess. That means my nitrogen tribromide is the limiting. So any stoichiometry past this point, I'm going to use nitrogen tribromide. Alright, so now we can figure out our actual problem. If we have 0.3 moles of nitrogen tribromide, how many grams, as we're calculating mass, of sodium bromide can we form? So let's set that up. So I have 0.3 moles of nitrogen tribromide. I need to change that to moles of sodium bromide. So moles of nitrogen tribromide go on bottom again. Moles of sodium bromide go on top. Need some values there. So let's go back to our balanced equation. So there's 2 nitrogens for every 3 sodiums. So 2 nitrogens for every 3 sodiums. So I cancel out my moles of nitrogen tribromide, and then I do some math. Got 0.3 times 3, then I divide that by 2, and I get 0.45. 0.45 what? That's going to be moles of sodium bromide. There is our answer. Hopefully that wasn't too bad. Alright, let's do another one. So it says, how many grams of aluminum chloride? So once again, we're going to be looking for a mass, and it's going to be of aluminum chloride. Could be produced from 40 grams of aluminum. So I got 40 grams of this guy, and 40 grams of chlorine gas. So there's 40 grams of this one too. So once again, we got to do mole conversions because we can't compare masses. We got to compare moles. So let's do our mole conversions real quick. So I got 40 grams of aluminum. Put that over 1. I need to change that to moles of aluminum. So grams of aluminum's on bottom. And I got 1 mole of aluminum on top. Well, aluminum has a molar mass of 27 grams. So I do 40 divided by 27. I get 1.48. Got 1.48 moles of aluminum because grams canceled out. Next I do chlorine. I have 40 grams of chlorine gas. So 1 mole of chlorine gas is equal to how many grams of chlorine gas? Well, elemental chlorine weighs 35, so if I have 2 of them, that's 70. So I got 70 grams. So 40 divided by 70 is 0.57. So 0.57 moles of chlorine gas. Alright, now you can figure out which ones are limiting reactants since we got moles. Let's look at our balanced equation real quick, take a little guess. So I need 2 aluminums for every 3 chlorines. So I should have a higher amount of moles of chlorine. Doesn't look like we do right now, so let's see if we can figure it out mathematically. So I'm going to start with aluminum. And I'm asking myself, how many moles of chlorine gas do I need to fully react 1.48 moles of aluminum? So I got 1.48 moles of aluminum. That's over 1. So moles of aluminum go on bottom. I'm changing it to moles. Chlorine gas, it goes on top. Now we use our balanced equation. There's 2 aluminum for every 3 chlorine. Moles of aluminum cancel. So I do 1.48 times 3 divided by 2. So I need 2.22 moles of chlorine gas. So that's how much I need. Well, how much do I have? Well, I have 0.57 moles of chlorine gas. Do I have enough? I need 2.22. I have 0.57. I do not have enough. The left number is larger. That means it's limiting. So chlorine gas is our limiting reactant that makes aluminum our excess reactant. Now we can do our regular stoichiometry. We're going to use chlorine. We're going to forget about aluminum unless it asks anything about it, in which case it doesn't. So we're looking for how many grams of aluminum chloride from 0.57 moles of chlorine. So we got 0.57 moles chlorine gas over 1 moles of chlorine gas on bottom. I'm changing it to moles of aluminum chloride. We need a balanced equation to set up our ratio. So there are 3 chlorines for every 2 aluminum chlorides. So 3 chlorines for every 2 aluminum chlorides. That's what our balanced equation told us. But we don't want to stop there. We need to change it to grams. Once we got moles, we got to change it to grams. Right now, these moles of chlorine are canceling out, leaving us with moles of aluminum chloride. But we need grams of aluminum chloride, so we want to set up an extra step. Since moles of aluminum chloride is on top, moles of aluminum chloride will go on bottom. I'm changing it to grams of aluminum chloride. So 1 mole of aluminum chloride is equal to how many grams? Aluminum weighs 27, chlorine weighs 35, and there are 3 of them. So we add all that up, and we get 132 grams for the molar mass. This will cancel out moles of aluminum chloride, leaving us with grams of aluminum chloride, which should be our answer. So 0.57 times 2 divided by 3 times 132, and I get 50.16. So theoretically, we should produce 50.16 grams of aluminum chloride. And there is our answer. Let's do one more. So we got 250 grams of aluminum sulfide, and it reacts with 500 grams of water. What mass of the excess reactant remains? How much aluminum hydroxide will form? So now we got 2 questions we're solving for. Let's pick out our information first. So I got 250 grams of aluminum sulfide. So this is 250 grams. I got 500 grams of water. And how much aluminum hydroxide will form? We're going to assume that is in grams. Alright, now we got to do our mole conversions. So I got 250 grams of aluminum sulfide. So 1 mole of aluminum sulfide is how many grams? Aluminum is 27. There's 2 of them. Sulfur is 32. And there's 3 of them. So we add all that up. We get 150. So grams of aluminum sulfide cancel out. So 250 times 1 divided by 150 gives me 1.67 moles aluminum sulfide. Next we can do water. We got 500 grams of water. That's over 1. So 1 mole of water is 18 grams. Oxygen is 16. There's 2 hydrogens. That makes 18. Grams of hydrogen cancel out. 500 times 1 divided by 18. I get 27.78 moles of water. So I have a lot of moles of water, not too much aluminum sulfide. My balanced equation says I need 6 times the amount of water as I do aluminum sulfide. So if I got, even if we had 2 moles of aluminum sulfide, 6 times that amount, I would need at least 12 moles of water, and I definitely got that. So I'm going to make a prediction that aluminum sulfide is my limiting reactant here. But let's check it just to make sure. So if I got 1.67 moles of aluminum sulfide, how much water will I need to fully react that 1.67 moles of aluminum sulfide? So let's set that up. So I need moles aluminum sulfide to cancel. I'm going to change it to moles of water. Now I use my balanced equation. It's 1 to 6. So there's 6 waters for every 1 aluminum sulfide. So moles of aluminum sulfide cancel. So 1.67 times 6 divided by 1. I need 10 moles. 10 moles of water. That's how much I need. Well, how much do we have? Well, I have 27.78. So I most definitely have enough water. Since the right number is larger, that's your excess. Water is your excess. And if water is excess, aluminum sulfide is your limiting. So any stoichiometry we do, we're going to use aluminum sulfide from here on out. But our first question is, what mass of excess reactant remains? So let's do that real quick since we have it set up right here for us. Now if I have 27.78 moles of water and I need 10, or to say I'm going to use 10, how much do I have left over? Well, 27.78 moles of water minus that 10 moles of water leaves me with 17.78 moles of water in this reaction. But we need mass. So let's do a quick conversion factor right here. So 1 mole of water. So 1 mole of water is equal to 18 grams. That cancels. That cancels. So 17.78 times 18. So we're going to have 320.04 grams of water left over. So there's that first answer. Alright, now we got that answer. I'm going to clear some of this off so I can have room to work. So erase this out. Alright, now we're just doing regular old stoichiometry. So if I got 1.67 moles of aluminum sulfide, how much aluminum hydroxide can I produce? So 1.67 moles of aluminum sulfide over 1. I'll put moles aluminum sulfide on bottom. I'm changing that to moles of aluminum hydroxide. Now I need my balanced equation. There's 1 aluminum sulfide for every 2 aluminum hydroxide. So this is 2, that's 1. So this will cancel out my moles of aluminum sulfide. I need to change now moles of aluminum hydroxide to grams. So 1 mole of aluminum hydroxide is how many grams? Let's use our periodic table to figure that one out. So aluminum is 27, oxygen is 16, and there's 3 of them, and then we got 3 hydrogens. So aluminum hydroxide is 78 grams for its molar mass. So our moles of aluminum hydroxide cancel out, and then at the end we should have grams of aluminum hydroxide. So let's knock this out real quick. We got 1.67 times 2 divided by 1 times 78 divided by 1. So I should produce 260.52 grams of aluminum hydroxide for our second answer. And that is limiting reactant practice. Or just keep practicing, practicing, practicing till you can't miss it anymore. Hope this video helps. And as always, good luck on your tests.